In this video tutorial, we will learn how we can create a medical chatbot with Llama 2. So here you can see the complete architecture. So first of all, I will upload a book. Either it can be a PDF file or it can be a book. And I will extract the data from that book or PDF file. So let me just show you. So here you can see that we have the book, Encyclopedia of Medicine. I will first upload this book and I will extract all the data from this book. And I will, after extracting all the content from this book, I will store that content into a vector database. Okay. So when we start asking questions with our chatbot using the information extracted from this book, our chatbot will give us the response to our query. Okay, so this is the book. So you can see that it's a very long book. It has 637 pages. You can see over here. I will extract all the data from this book. I will be extracting the data from all these 637 pages, and I will save this data into a vector database. And then when we chat with our chatbot behind the chatbot, we will be using Llama 2 model. So when I ask a question to my chatbot, it will give me the response by finding the answer from the data which we have extracted from this book. Okay, so let's go back to the architecture. So now you can see that first of all, I will just extract the data from this book or PDF file. So after extracting the data from this book or PDF file, I will split that data into multiple text chunks. So now you can see that we have 637 pages. So now after extracting the data from these 637 pages, I cannot pass this data directly to my Llama 2 model. The reason is that in the Llama 2 model has input token limit. Okay. So it has a Llama 2 model or other OpenAI model have an input token limit. Like with Llama 2 model, we have an input token limit of 4096 tokens, and one token has 4 English characters. So it means we cannot pass more than, if you can see over here. So 6 to Llama 2. So Llama 2 has 4096 token limit. Okay. So we cannot pass more than 4096 token at the input of Llama 2 model. So 4096 token means it is around 16,000 English characters. But if you see that our book has 637 pages. So in this 637 pages, we will definitely have more than 16,000 English characters. Like a single page might contain 16,000 English characters. So we cannot pass that data directly to the Llama 2 model. So what we do is we basically split the data into multiple text chunks. Then we create embeddings for each of these text chunks. Okay. So after creating embeddings for each of the text chunks, so embeddings are basically embeddings are basically vectors which contain floating point numbers. So you can see that for these text chunks, we will have this type of embedding 0.1, 0.2, 0.3. Okay. So in this is how we have the embeddings. So embeddings are basically vectors that contain floating point numbers. Okay. So we convert each of the text chunk into embedding, or you can say that we create embeddings for each of the text chunk. Okay. So for example, if we have 10 text chunks, so we will have 10 embeddings. Okay. So embeddings are basically vectors which contain floating point numbers. The reason why we need to create embedding is that basically it reduces the size of the text chunk. Okay. And plus it also reduces the memory size. Okay. So what further on, so how you can determine how many text chunks you want to create. For example, when we just create text chunk, we define that each text chunk will have maximum number of 500 English characters or 1000 English characters. So if we just said, for example, 500 English characters, so each text chunk will have 500 English characters. And if we have 1000 English characters in total, so we will have 2 text chunks. If we have 2000 English characters in total in our extracted data, and we say that each text chunk will have 500 English characters, so we'll create 4 text chunks. Okay. So in this case, we will have around 2300 plus text chunks. Okay. and we will have in each text chunks we have 500 English characters. Okay, so we'll have more than 23,000 text chunks, and we will then create embeddings for each of the text chunks. Embeddings are basically vectors that contain floating point numbers. So after creating embeddings for each of the text chunks, we will save those embeddings into a knowledge base. So we will create a vectors database or a knowledge database where we will store all these embeddings. So we will store all these embeddings into a knowledge base. So we will create a vector database in which we will store all these embeddings. So we will create a vector, or we will store all these embeddings into Pinecone vector database. Okay. So we will store all these embeddings into Pinecone vector database. So if I just write over here and show you Pinecone. So basically in Pinecone, we save our embeddings in cloud. Okay. So if you just want to create an account on Pinecone, you can just click over here, sign up for free. So in Pinecone, our embeddings are stored in the cloud. So you can see that I have already created an account. So you can just create your free account. Okay. And then you will, if you just go to over here, you will find your API key over here. And in the indexes, if you want to just save your embeddings, you first need to create an index. Okay. If you click on create index, you will be create index in which we will store your embeddings. Okay. So here you just need to write your embedding name. So if I just write LangChain, okay. So here you will just need to write the dimension. So it depends on your embedding model. So I'm just using Hugging Face embedding or sentence transformer embeddings. So it has 384 dimension, and you will just click on starter. It's free, and you just click on create index. Okay. So you can see that I have a free subscription, so I can create maximum one index. So you can just if create one index, so you can just follow this. It's 384. Please remember dimensions are 384. So you can just create your index by following this approach. Okay. So I've already created this embeddings index, like you can see over here. And here you can see that I have just stored my embeddings. So you can see that in this case, I have 25,186 text chunks. So the number of text chunks you have, the number of vectors you have, okay, in your knowledge base. Okay. So in this Pinecone knowledge base or vector database, I have stored all my embeddings. So you can see over here, all my embeddings are stored into the cloud knowledge base, which is Pinecone knowledge base. So here you can see that we will store all those embeddings into online knowledge base or online cloud data vector database, which is Pinecone. Okay. So after we have stored all those embeddings into Pinecone online vector database, so in the next step, when the user asks a question or a query, we will create embeddings for this question. So you can see that here we will have embeddings are basically vectors which contain floating point numbers. So we'll have embeddings like this. Okay. So when the user asks a question, we will create embeddings for that question, and then we will do a semantic search, similarity search. And then after doing the similarity search, we will rank top 3 answers which we get from our knowledge base. Okay, so the user has asked a question. We have created embeddings for that question, and then we will find the answer for that question into our knowledge base. So in our knowledge base, we have stored all the embeddings for the book. Okay, a medicine book which I have showed you in the start. So now we will find top 3 answers that for the question that the user has asked. Okay. So after getting the top 3 answer, you can just change this ratio to if you want to guess top 5 answer or top 10 answer, you can vary the K value. So after getting the top 3 answer, I will just pass these 3 answers to the Llama 2 model, and I will pass the question directly to the Llama 2 model as well, and Llama 2 model will generate a natural response. So this is how it works basically. So this is a complete architecture. So let's move towards the code implementation part. So here you can see that I've already written the complete script for this project. So before we go ahead, let me just show you which Llama 2 model I'm using over here. So in my system, I have 8 GB of RAM, and so I have the RAM. I have a CPU based system, and it has 8 GB RAM. Okay, so the Llama 2 model I will be using optimized or uh, GGM Llama 2 model in GGML format. Okay, so let me just show you which Llama 2 model I will be using. Just give me a minute. In this tutorial, I will be using this Llama 2 quantized model. The reason why I am using Llama 2 quantized model is that although Llama 2 model has a very good performance, but you know that the Llama 2 models require a lot of memory. Okay, so to overcome this limitation or this issue, like they consumes a lot of memory, we can do we can basically quantize our model. Okay. So what does in quantization we do is basically we reduce the memory footprint while maintaining the model performance. So here is the quantized version of Llama 2 model. You can see over here. I will be using this quantized model. And if I just go to files and version, so you can see over here, I will be using this uh, Llama 2 model with 7 billion parameters, and I'm using Llama 2 chat model. And here I'm using with the model with 4-bit. Okay, so you can see we have the 8-bit model as well, but I'm using 4-bit model because the 8-bit model will consume around 10 GB of RAM, but I have 8 GB of RAM in my system. So I will be using this 4-bit model because it will consume around 5.5 GB of RAM. Okay, so if you have around 16 GB of RAM in your local system, in your system CPU, so you can just use this 8-bit model. But if you have 8 GB of RAM like myself, so then you can use this 4-bit model over here. I have just already downloaded this model. So you can just click over here and download this model as well. Okay. So I have already downloaded this model. Okay. So if I just go back towards the code, so now you can see over here in my models folder, I have just placed this model over here. You can see this. And here I'm just using this model. Okay. So in my project, I have just created a models folder, and inside this model folder, I have this model. Okay. I have the 8-bit model as well and 2-bit, but I'm using 8-bit model takes around 1 hour and 30 minutes to give me one response, one answer. But with 4-bit model, I will get the response in 30 seconds to 1 minute. Okay. So I will be using this 4-bit model, and after downloading the model, you can create a folder by the name models and just place this model over here and nothing else. Okay. So here you can see this, we have the model over here. So to implement the models in the GGML format, so like you can see over here, uh, as this model is in the GDML format, the quantized model, we will use C transformers library. So C transformers library provides bindings for the models that are implemented in the GGML format. So we are using C transformers library over here. And here you can see that I've just passed my Pinecone API key over here. So let me just show you. So if you just go over here, this is your Pinecone API key. Okay, so you just need to copy this from here and just paste it over here. So along with this, you can see over here, I'm just using Pinecone API environment. So let me just show you Pinecone API environment. So this is your environment. You just need to copy this from here and just paste this over here as well. So here I've just pasted this Pinecone API environment. Okay. So here you can see I've just imported directly loader. And if you just see over here in my data folder, I have this medical chatbot.pdf file, which I've just shown you already. So let me just show you again this. Okay. So this is the medical chatbot.pdf file which I have placed in my data folder. Okay. So in this data folder, I have this medical chatbot PDF file. Okay. So now here I'm just loading the PDF file and extracting all the data which we have in the PDF file. So here I'm just loading the PDF file and extracting all the data from this PDF file. So here I'm just calling this function load PDF file, and from this file. So if you have multiple PDF file over here, it will extract all the data that you have in those PDF file, and our extracted data will be saved in the variable extracted data. Okay. So now after extracting all this data, we will split the data into text chunks as I already told you. So let me just show you again. So now you can see that after extracting all the data, we will split the data into text chunks and then we will create embeddings for each of the text chunk. And after creating embeddings for each of the text chunk, then we will create a knowledge base. Okay. So I have extracted the data. So now I will create embeddings for each of the text chunk. Okay, so now I will just, after I have extracted the data, so now I will just split the data into small chunks and each chunk will contain maximum 500 English characters and there will be overlap of 500 characters as well. So you can just set to 20. Okay, so after extracting all the data, I have just split the data into smaller text chunks. Okay, and each text chunk will have 500 English characters maximum and there will be 20 characters overlap. Okay, so after splitting our data into small text chunks, then we will create embeddings for each of the text chunks. So I'm just downloading Hugging Face embeddings and you can see over here, I'm just finding the dimensions of my embedding. So it is 384, okay, which I have just passed into the Pinecone as well. So now after here, you can see that I'm just downloading embeddings from Hugging Face. I'm using sentence transformers embeddings. So after creating embeddings, okay, or after downloading the embeddings from the Hugging Face, I'm just initializing Pinecone over here. Pinecone is our online cloud knowledge database where I will store all the embeddings. Okay, so now you can see over here. So just comment this out and just keep this up. So you can see over here, after downloading the embeddings from Hugging Face, after downloading the embeddings from the Hugging Face, we will create embeddings for each of the text chunk, and then we will store those embeddings into Pinecone knowledge base. So Pinecone is an online cloud knowledge base. So we will store all those embeddings into our Pinecone knowledge base. So I have already done this and saved my embeddings into the Pinecone knowledge base. So let me just show you. So over here, you can see indexes. I have just saved all my embeddings. So I have split my text into 25,186 text chunks. And here I have 25,186 embeddings. Okay. So here I have just saved all those embeddings. Okay. So in that case, if you have already saved your embeddings into Pinecone knowledge base, and if you rerun this script, you don't need to save the embeddings again into the Pinecone knowledge base. You can just comment this, and if you have already saved your embeddings into a Pinecone knowledge base, then you just need to use the existing embeddings which you have saved into the Pinecone knowledge base. Okay, so here we are doing similarity search and we are just finding top 3 answers the user has asked. Okay, so here I'm just creating a prompt template, and this is the prompt template I've created and you can just see. And here I'm just initializing my Llama 2 model over here. And here I'm just doing the question answer with my chat model. And here I've just passed the Llama model and chain type is stuff. And here we are setting the document search. In document search, I have saved all my, so documents search basically is the variable which contains all my embeddings, okay, which I have saved into the Pinecone knowledge base. So Pinecone is an online cloud knowledge base which we have saved, where we have saved all our embeddings, and all these embeddings are also saved in the doc search variable as well. Okay. And here I'm just passing the prompt template, and it will also return me the source document where we have find the answer. So in the chain type voice, I'm just passing the prompt. Okay. So here I'm just creating a while loop, and when the user asks the question, we get the response as well as a source document. If the user types exit, we will just close our chat code. So let's run this and let's have a chat with our medical chatbot. So this might take a few seconds to execute. Oh, you can see here we have 7,020 text chunk, and here you can see that we have our embeddings model has dimension 384. So I will just ask first question, what is, okay, so this is the question which, the answer of this question is in the book, and I am just asking this question. So let me just show you over here in the book as well. So here we have this question, acetaminophen. So you can see over here, and I'm just asking this question over here as well. And let's see whether we get the desired answer from our chatbot or not. Okay. So I have asked two questions and it has given me the response. It was taking around 30 seconds to 1 minute to generate a response. So I have just paused the video. So you can see first I asked what is actinomyces. So its answer is actinomycosis is an infection caused by the bacterium and primarily occurring in the face and neck region as a slowly enlarging hard red lump. And here we have the source document where it has extracted the answer. And the second question is, what is acupressure? Acupressure is a form of body work that uses pressure points and massage techniques to stimulate the body natural healing process and promote relaxation. And here we have the source document from where it has extracted the answer. So you can ask further questions and it will generate a response. So in this video tutorial, we have learned how we can create a medical chatbot. So that's all from this video tutorial. See you all in the next video. Till then, bye-bye.